What's up? Great day, everybody. It's still the great teacher Alcantara here with some more lessons to review for and basically more videos. And I am so sleepy, but we have to do this. And in this set of videos, we're going to start discussing what we have discussed in classes before, but well, let's just jump right into it. So for this first one, what we're going to talk about is none other than relations and functions. Okay, so let's start with our discussion for relations and functions. Our learning targets for this specific concept are as follow. First one is to define what is a relation and a function, followed by finding the domain and the range of a function, and then lastly, to differentiate what makes a relation and what makes a function through real-life examples and experiences. So we're going to discuss all three of those things. But of course, before we go there, it's important for us to understand that, again, these things, specifically this concept, is something that you guys could probably relate to because it is something that is indeed in real life. So let's start with trying to understand what relations and functions are with the help of different examples. We're joined by our lovely president and vice president. And for example, for this specific lesson, we may see different concepts or categories, and then we're not going to basically go through all of them, but we're going to focus on some of them. We can have the relations and functions using anime or heroes or gaming or music, K-pop, or even shows as our categories. So let's just jump right into the discussion. For example, we're going to see some things like this. For anime, we can have Gojo Sensei and the students, Nobara, Yuji, and Megumi. So we know that this is the teacher, Gojo, and then on the right side, that's students. So we can say that Gojo Sensei is the teacher of Nobara, same case for Yuji and Megumi. So you're going to see a lot of concepts like this because this first concept that I'm showing you is what we actually call as a concept diagram. It's a diagram itself. And there are two sides of it in this one. On the left side, we have the teacher. On the right side, we have the students. Later, we'll dive in deeper as to what this means. So far, what I wish for you to know is, or is to somewhat get used to how it looks like. So you have our teacher again, Aizawa Sensei, Bakugo, Midoriya, and then Todoroki. Same case with what we had earlier. Then lastly, we have Koro Sensei. And Koro Sensei is the teacher of Itona. Same with Nagisa and then Karma. That's it. And then let's jump right into a different category. For K-pop, we can see something like this. For example, we have here on the left side, the groups, and then on the right side, we have the companies. So we have the big three here, starting with Blackpink, who is under the company YG. Same with Red Velvet. Now, Red Velvet is also under a certain company, but for Red Velvet, it is SM Entertainment. And then for Twice, it's JYP. And that's it. And on the other hand, we have here as follow, groups, and then their company. We have, is this 17? I forgot, please don't hate me. I think this is 17, right? And then there are other YG, which is also under Pledges. And then Treasure, which is under SM. And then N-Hypen, which is under JYP. But with Belief, if I'm not mistaken. Please do not hate me. I'm not really fond of boy groups. But, of course, I have to try to listen to them so that I could somewhat understand my students better. But anyway, to continue, you can also look at heroes. We have these characters. We have Batman, Wonder Woman, and Superman, and they're all under the company of DC. Same case for Marvel. We have the following characters: Thor, Captain America, Iron Man. They're all under Marvel. And then let's go with shows. We have the show Stranger Things. We have our boy Will. Wish I could find my will to live. Just kidding. We have Dustin. We have 5, 4, 3, 6, 7. Blah, 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 blah. You make me feel 11 here. And then we have our boy with the Riz. And then Lucas. They're all under Stranger Things. And lastly, we have these characters from We Bare Bears. Panda, Grizz, and Ice Bear. They're all under We Bare Bears. Okay? And then gaming, we could have certain things like this. So Spider-Man and God of War, we can play that in PS4. Zelda and Super Smash Bros. Nintendo Switch, the specific titles. Next is We have video games such as Mobile Legends, Call of Duty. We can play that using our phones. And this one is a classic. Mario and Luigi Superstar Saga. That's my favorite game of all time. Tied, I guess, with Pokemon Emerald, I guess. These were my childhood video games. So, to conclude, we have our last example, this one for music. So, we have Posty, who created the album Hollywood's Bleeding. Really good album. Olivia Rodrigo got Sour. The Weeknd got Starboy, and of course our girl Dula Peep got Future Nostalgia. And lastly, we have classics here. Paramore, who just got back. We have Brand New Eyes as one of their albums. Then Linkin Park, Hybrid Theory. After all this time, Hybrid Theory is still the best. Then here we got Queen with Hot Space, and then lastly the Beatles with Abbey Road. So as you can notice, with different categories, I showed you different examples, and all of them showcases the concepts of relations and functions. As you can observe, there are two sides again. We have the left side and the right side, and we have arrowheads. This again is an example of a diagram to present or represent relations and functions. Now, let us focus with some of these examples. So let's process them. Mainly, as you can notice, there is a particular format or pattern for all the teachers and students that we have here. As you can notice, the question or the guide question we're being asked is, what can we say about the relationship of the elements on the left side to the elements on the right side? So basically, the word elements there is highlighted because I'm trying to somewhat help you guys remember where we used that word before. So the word elements is maximized or was maximized and is still being maximized using the concepts of sets. That is something that was discussed during grade 7, wherein there are sets of concepts and then there are certain elements under them. So on the left side of this example, we have the set of teachers, and the elements are the teachers, and then on the right side, we have the set of students, and the elements are this particular students. So this kind of example, you can notice that the diagram has arrowheads from teachers to students. So this one, we can say that for every one teacher, there are a lot of students. This is actually true to real life. For example, the great teacher. I am your teacher. I'm the only great teacher there is. Just kidding. Onizuka is the OG, but I'm the second probably. But I'm your only teacher, and then you're a lot of students. That implies a relationship that is what we call one-to-many. Because this relation is between teachers and students. So one teacher corresponds to many students. Okay? It's a one-to-many correspondence. One teacher, many students. Example number 2, as you can notice here with the groups, they're all simply under one company. And if earlier it's one to many, this one I think is pretty much straightforward. We have one group, one company. We can say that this is simply one to one. That's the correspondence that it has. And then lastly, we have the superheroes and their company. This time around, we have a lot of superheroes under the same company. So we can say that since there are many superheroes and one company, the correspondence here is none other than many to one. So as you can notice, we're only using two words here, one and many, to showcase the relation. So it's either on the left side, it's many. As you can notice, there are many elements on the left side and there's only one element on the right side. Sir, but in the given there are tons of superheroes and then there are two companies. What I'm trying to say here is, since this is a diagram, focus with the arrowheads and what it's pertaining to. So basically these are just two examples that I put in as one, but still it follows the same concept of many to one. Okay, I hope that clarifies it. Now it's important to remember that the pairing of elements of one set and the elements of a second set is what we call as a relation. At the same time, these relations can be written as ordered pairs. So later, you will understand as to why the concepts or the lessons, RCS and relations and functions go hand in hand. It's just important that you understand first how it is before we make sense of it. So do not worry, later on our sets will no longer be categorical, they will be numerical. But it's a step-by-step process to get you there. Now, of course, for ordered pairs, that is XY. The first ordered pair, again, as mentioned last time, is abscissa, and then the y is the ordinate. And then at the same time, it's important to remember that, again, there is a set in these examples. So this is where our second learning target comes in. Wherein you have to take note the set of the first elements, basically the set of x values or the set of the ones on the left, is what we call as the domain of the said relation. While the second element, the set of that, all of those under the right side, is what we call as the range of the relation. This kind of concept is better understood if we have actual examples. So let us just jump right into it. So let's say that we have the following. We have the superheroes and then we have the company. As you can notice again, when we write ordered pairs, we start with the x value followed by the y. Sir, what is the x value and what is the y value if you're given with a relation that is a what they call this, a concept diagram or a diagram itself? Always remember again that left side is what comes first and the right side is the next one. Same case with ordered pairs, the x comes first followed by the y. So the ones on the left side is under what we call a superheroes, right? So we take note of that as the x values, and since the company is on the right side, we take note of that as the set of y values or value depending on the case. So as the ordered pair goes, we have the pair of Batman and DC, as Batman corresponds to DC, Wonder Woman corresponds to DC, Superman corresponds to DC. So that's how it works. Now for the domain, as you can notice, there's a difference with the symbol that we're using. For ordered pairs, we are using, again, parentheses, but for domain and range, we are using brackets because we are showcasing the concept of sets. Okay, so that's how we write it properly, this kind of symbol. So the domain, again, is the set of x values. That's why we have Batman, Wonder Woman, and Superman under it. While for the range, it's the set of y values, and we only have DC there. So that's our answer. Okay, and then again, the relationship is many to one. So that's how it works. So let's have another example. So let's say that we have the groups, the big tree right here. So we have our first ordered pair here as Blackpink YG, and then RV or Red Velvet, and then SM, then lastly Twice and JYP. Okay, so that's it, as easy as that. Based on the diagram, based on the arrowheads, you can do it quickly. And then next, for the domain, you have Blackpink, Red Velvet, and Twice. And always remember again how to write domain properly. And then lastly, for the range, we have YG, SM, and JYP. So that's how it works. Then for the relation, this is 1 to 1. Lastly, I think it's the last one if I'm not mistaken, we have the games and the devices. We have Mobile Legends or ML to phone. We have COD M to phone, Mario to Game Boy, and then Pokemon to Game Boy. Our domain again is the set of x values, the ones on the left. We have ML, COD M, Mario, and Pokemon. So for the range here, we simply have phone and Game Boy. Then lastly, the relationship here is many to one because there are many games that can be played in a device. That's how you can look at it. That's why it's many to one. So there are tons of games that you can play in the Game Boy. That's why it's many to one. So to continue with this, we have one more example. Oh yeah. So we have, for example, Gojo Sensei. So we can say that we have Gojo Sensei and Nobara, Gojo and Yuji, Gojo and Megumi. Domain is, of course, it's apropos that the domain is the guy who can do the domain expansion. We have Gojo Sensei right there. Then for the range, we have the students, Nobara, Yuji, and Megumi. And again, this is 1 to many. Okay? And these are the things that we have to remember. First, that again, it's been stated earlier that a relation is a set of ordered pairs. There are 3 correspondences that we have taken notice of, right? We have the 1 to 1, 1 to many, and many to 1. There is also a special kind of relation called as a function. Now, this is the one thing that we have emphasized in our first learning target, that we're going to define what a relation and what a function is. And we're now going to what a function is, since we have already discussed through different examples what relations are. So a function is basically also a relation, wherein the first element in the ordered pair corresponds to exactly 1 second element. So what this implies is that, again, the term is exactly 1. Later, we can take note of this highlighted term in order to guide us as to how to put our answers correctly. So in this case, always remember that all functions are relations, but not all relations are functions. So among the three that we have, one-to-many, one-to-one, and many-to-one, those are all relations, but not all of them are functions. And that's the thing that we have to figure out. So it's important again to start with examples. So below is the relation that shows the correspondence between best friends, besties, and their favorite genre for TV. So we have the following people, Kim and Joy. So our first ordered pair is Kim and sci-fi. Then we have Kim and horror. Then we have Joy, comedy. Then we have Joy, then romance. Then for the domain, we only have Kim and Joy. Then for range, what we have here is comedy, sci-fi, horror, and romance. Now, here's the question. What do you think? Is this a relation or is this a function? Okay, so earlier it was stated that, again, that the first element should only correspond to exactly 1 second element. That was a term. So this one right here is an example of what? Only a relation. It's not a function. It's just a relation. Because the correspondence is one person, many genre. I hope you guys are understanding it now. Later we'll dig in deeper to this. Don't worry. Next, the relation below shows the correspondence between the students and the number of their siblings. We have Wendy with 1 sibling, Irene with 2 siblings, Jenny with no siblings, and Lisa with 1 sibling. So in this case, the domain is as follows: Wendy, Irene, Jenny, and Lisa. While for the range, we have 0, 1, 2. So is this a relation or is this a function? This right here is actually a what? A function. And it's because the correspondence is many to one. Why is it many to one? Sir, Irene is 1-to-1 to 2. The Jenny is 1-to-1 with 0. But again, we also have the example of Wendy and Lisa being or corresponding to 1. So that's many to 1. Okay? So that's how it works. So in this case, as we continue, we can also show an example like this, where the correspondence between the number of visitors for a birthday party and the number of souvenirs that will be given. So our first ordered pair now, again, this is now numerical, so we're transitioning to it smoothly. We have 1 visitor, 2 souvenirs, 2 visitors, 4 souvenirs, 3, 6, 4, 8. Those are our ordered pairs. So the domain here is 1, 2, 3, and 4. Then our range here is the ones on the right side, that is 2, 4, 6, 8. And this right here is actually a function because the correspondence is 1-to-1. Now, let's try to summarize the concepts here. We have the examples again that the correspondence is 1-to-1, 1-to-many, and many-to-1. Now, you're trying to figure out, earlier we have noted that 1-to-1 is a function, 1-to-many is a relation, many-to-1 is a function. So this is what I want you to understand. Earlier in the definition of terms, we said that all functions are relations, but not all relations are functions. So among these three earlier, we have identified that 1-to-many is actually not a, again, we have identified again that 1-to-many is not a function. It's just a relation. Now, we're going to go back to earlier, the highlighted phrase in our definition of terms, that it should only correspond to exactly 1 second element. So as you can notice from the correspondence itself, to answer that question, or this question right here, we can notice that something is a relation or function based on its correspondence alone. Since this is 1-to-1 to 1, it only corresponds to exactly 1 second element. Always remember, the one on the left is our first element and the one on the right is our second element. So that's how we answer it. many to 1, so it corresponds to exactly 1 second element again. That's why it's a function. So to answer the bonus question on the screen, what correspondence, what is the many to many? Like, is it a relation or is it a function? So the answer there, it's a relation because it corresponds to many. And that's it. That's how it works. So in this thing right here, we were able to somewhat differentiate and define what relation and functions are with the help of real life examples and diagrams. So for the next part of this discussion, we're gonna give out examples of relations and functions not only with diagrams, but now we're going with ordered pairs alone, just like the ones that we have been listing, and also a table of values, which is something that I'm going to introduce, and then with the graph. So we're gonna go there. Okay, what you're seeing on your screen right now is a worksheet from Pizzazz, which you can check out. These are things that could help you out with learning more about different concepts. And they are using worksheets and some corny jokes, some dad jokes that I think some of you guys might and probably will love to hate. These question that we have here is, what did the baby porcupine say when it backed into a cactus? So what we're gonna do here is we're gonna determine which of the relations below are functions, and we have to somewhat cross out our I think we're gonna cross out the relation the functions here. So as you can notice, we're gonna make use of what we have been talking about earlier, which is that functions corresponds to exactly 1 second element. This right here is going to be our guide in this specific concept. Exactly 1 second element. So let's start with our first item. We have negative 2, 7, negative 1, 5, 0, 3, 1, 1, and 2, 1 as our set of ordered pairs. So again, we have to take note of if it follows the concept that that ones on the left side corresponds to exactly 1 second element. So sir, what do we do if it's ordered pairs? So basically, again, remember, if it's an ordered pair, it is written as xy. So our first element is x, and our second element is y. That's how you can look at it. So in this case, as you can notice, negative 2, 7, negative 1, 5, 0, 3, 1, 1, 2, 1 is it's one element corresponding to just, you know, exactly 1. And what kind of correspondence is this? Actually, this is many to 1. Because as you can notice, yes, the 1 repeats here, and you have 1 and 2 corresponding to it. It's a many to 1. It's a many to 1. So this is actually a function. Later, I'll just write f and r so that it will be much faster. So next we have negative 720, 3505, negative 206, negative 4, negative 6, negative 9, 4, 4. So this is also a case of a function because as you can notice, there is no like one element corresponding to many elements. Okay, later I'll show what I'm trying to say here. Yes, there is a repetition with the 5 and the 5 here, but again, this is just a many to 1 kind of situation. It's a many to 1. So let's check out our part below. So what we can cross out. So far 1 and 2. So we will cross out 1 and 2. Okay, so let's go continue. The third one, we have 4, 8, negative 3, negative 2, 9, 6, 2, negative 1, negative 4, negative 5, 2, 7, negative 8, 0. Now, I want you to pay attention to two ordered pairs here. Let me just change the color so you can see it. We have 2, negative 1, and 2, 7 here. These two things somewhat gives it away. As you can notice, again, going back to our concept, it should be like one element should correspond to exactly 1 second element. Or is it still the same concept that we have earlier? Earlier, what's been repeating is just the y values. And we're good with that, with 5 repeating, because it's a concept of many to one. But here, as you can notice, the one that repeated is not the y value, but instead the x. So is this still many to one? No. This is now 1 to many. So one element, which is 2, corresponds to many numbers, which is -1 and 7. So this is actually a relation. So that means we're keeping number 3. So number 3 is part of the answer later to the secret message. Next, let's go now with an ordered pair. With table of values. So a table of values is basically like a diagram, but this time around there are no arrowheads. Instead, it is under a table. It's still the same thing. You don't have to panic with it. As you can notice here, there is no repetition at all. This is 1 to 1. Why is it 1 to 1? Each of the numbers on the left side corresponds to exactly one value on the right side. So this is also a function. Okay, so number 4, where's number 4? P. So we're gonna eliminate that. Let's go with the next one. Is there any repetition with x values? None. But is there a repetition of y values? Yes. Yes, here also. This is actually yet another function. This is now many to 1. So there are many, excuse me, it's the water in me. The many, you have -5 and -3, and they all correspond to one number, and that's 8. That's why it's many to 1. So we're going to eliminate number 5 also. Number 5 is eliminated. Then for 6, we have here -2, -2. This right here. Let's take note of that. -2, -2, 2, 2. So this is now not many to 1 or 1 to 1. This is 1 to many. Because -2 is just one number, but it corresponds to many numbers, -7 and 5. So this is a relation. So number 6 is part of the answer. Now, I would like to clarify now the pattern that we're noticing for items 1 to 6. Basically, it's important to be reminded. I'll put it here, the note. If the x, which is the first element, repeats, it's a relation. Am I correct with that? Yes. If the x values, or if the x or the first element that we have the -2, the 2 as an example, and here also the 2 and the 2 for number 3, because it repeated in our given, that makes it a relation automatically. Relation in what sense? It's 1 to many. Okay, so that's the pattern. So that again, I'm teaching you the usual way and then the pattern finding. So that's our pattern. Again, if the first element, which is x, repeats, it's a relation. Now let's go with the graphs. Now with these graphs here, we're not gonna dive in deep with this, but we're gonna take note of a lot of special things here, because we're gonna do something for items 7 to 12. And this concept that we're introducing is what we call as the vertical line test. The vertical line test is basically a test as to how or if the graph is an example of a function or not. So what you're going to do in the vertical line test is simple. What you're going to do is simple. Draw a vertical line anywhere in the graph. Draw a vertical line on the graph. Anywhere will do. If it passes through exactly 1 point for all. This should be true for all. It is a function. So to put this in practice, let's go with number 7. Let's say that I'll draw a vertical line here for this one right here. As you can notice, again, it only passes through 1 point. But again, it should be true for all. So let's try to draw more. I'll use different colors so that you can see it. I'll try not to put arrowheads anymore so that the time is not being wasted, because it's already taking me a while to move this ruler right here. So there's only 1 point it passes through in the given. Same with this. Same with this. Same with this. And same with this. So as you can notice, the vertical line test, you're not just going to draw one line. You can draw a lot of them, and it's fine. As long as you follow the concept that when you draw a vertical line or vertical lines, it passes through exactly 1 point only for it to be a function. So as you can notice for item number 7, it only passed through 1 point for all. It's true for all. So we consider number 7 actually as a function. So we can eliminate the letter number 7 here. So this is eliminated. Same case with number 8. For us to not to waste time, we can draw any vertical line there, anywhere. Oh, sorry. And it only passes through 1 point in the line that is given. The line that we're talking about here is not the x-axis and the y-axis. We're talking about the given itself. So this is also an example of a function. So number 8 is also a function. Now, let's go with number 9. That's why I'm saying it should be true for all. That's the term, for all. Because if you draw a vertical line here with the endpoint, or sorry, with the vertex of this given parabola, which will be your lesson in the future, it only passes through 1 point. Let's just say it's a right one. But if you draw it here, it passes through not 1, but 2 points. First point here, second point here. So that makes this not a relation anymore. Not a function anymore. It's now a relation. Because of that. So you're simply going to draw a vertical line. Again, if it passes through 2 points, that's automatically a relation. So we're going to keep number 9. We're going to keep number 9. And how about for 10? Again, that's the same thing. If you draw your vertical line somewhere at the end of the circle, at the edge of it, it might not look like it, but again, I'm just terrible with this ruler thingy. It could pass through 1 point, but again, it should be true for all. So if I draw somewhere here, we could take note of the 2 points here and here. So this makes it as a relation also. So in that case, we're gonna keep number 10, which is h. Now for number 11, it's not a straight line, but if you draw any line there, anywhere, it's just gonna pass through one specific point. Why is the ruler not working? Ayan siya. So this is basically a function. So we're gonna eliminate number 11. Same case with number 12. Draw any vertical line there. Blah, 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 this, that. Okay, I actually gave up with the ruler, but this is also a function. So we're gonna eliminate number 12. So again, this is what we're calling as the vertical line test. You're gonna use this more in your future lessons in graphing and different grade levels. So it's important that you have the idea again that simply draw any vertical line anywhere, and as long as it is true for all, we can determine what is a function. Okay? As long as it passes through exactly 1 point. Again, true for all. Now, what's the secret message here? Why is it H-I-M-A? Is it Hima? No. What did the baby porcupine say when it back into the cactus? It's actually Hi-ma. Get it? Because the cactus has, thorns. Same with the porcupine. Haha, Hi-ma. Funny, right? Anyway, I don't know if this is still funny to you guys, but yeah, that's basically the joke here. So you may practice this also on your own. They have more examples, but not all of them are plainly grade 8. It's more about different kinds of algebra. So you may check out Pizzazz for that. Okay, so with that being said, that's it for this concept about relations and functions. Well, that ends this video lesson, and I hope you learned something new, or you were able to somewhat refresh your memory with things. And I hope this helps out. If you have more questions for clarification, you may maximize the chat box below. Let's just pretend that I'm actually a YouTuber who will comment or reply to messages in the comments. Who knows? Maybe I will. Maybe I won't. Who knows? But hope you guys learned a lot from these videos. And I hope you are doing well. And you are able to rest. At the same time, you're not panicking. Just keep on learning. And hopefully, math will go right with you. Because at the end of the day, mathematics is for everyone. Everyone is a math person. Hashtag, I am a math person. I'll see you guys. Always remember what's up. That's respect.